Okay, I'm going to ask volunteer to read the definition of an infinite limits. Okay, you're going to read this paragraph, okay, and also you're going to read this definition as well. Okay, so read both definitions. Okay, yeah, these words look smaller. I hope you guys can still see it. Let me see whose turn. Simon?
Okay. It says, let f be a function defined on both sides of a except possibly at a itself. That the limit of f of x as it approaches a equals infinity means that the values of f of x can be made arbitrarily large as we please by taking x sufficiently close to a but not equal to a.
Okay, yeah.
It says, let f be a function defined on both sides of a except possibly at a itself. That the limit of a x approaches a f of x is going to be negative infinity. It means the values of f of x can be made arbitrarily large and negative by taking x sufficiently close to a but not equal to a.
Okay, very good. Thanks. Okay, so let's look at a bigger equation. Okay, bigger one. Let's look at this. If we encounter a limit equation looks like this, what does this limit equation, tell us?
Tells us that on the graph it's going to be vertical asymptote approaching to the top.
Yes, that means when x approaches a from both sides of a but not equals a, x cannot be equals a, the y value will be infinity what? Large. Okay, very, very large. So this is a graph will illustrate that when x approaches a from both sides of a, so the y value will be very, very large. Okay, arbitrarily large. Okay, as large as possible. Okay, and then if this is the case, okay, there is a vertical line, okay, that our graphs will approaches to but never touches. Okay, approaches to the vertical line, and this vertical line has equation x equals a. Is called what? A vertical asymptote of this graph, okay, of this function, y equals f of x, okay. This is when y value goes to positive infinity, okay. The other definition is telling us, okay, when x approaches a from both sides, okay, well, the y value goes to what? Arbitrarily large negative. Oh, looks like this, okay? Well, then we can also get a vertical straight line which has equation x equals a, and this x equals a is called what? The vertical asymptote of the graph, okay, of the function, okay, y equals f of x. Okay, so these two cases that are in general when x approaches a from both sides, x approaches a from both sides, either when y goes to positive infinity or negative infinity. Okay, well, for the definition of what? Vertical asymptotes. Okay, not only those two cases applies to give us the vertical asymptote. Okay, similarly, when we have one-sided infinity limits, okay, say these four other cases, okay, so the first case is when x approaches a from the left, y goes to positive infinity, okay, and then this is telling us when x approaches a from the right, y goes to positive infinity, okay. This case is telling us x goes to a negative, y goes to negative infinity, and then this picture is telling us when x approaches a from the right, y goes to negative infinity. For all of these one-side limits, okay, we also get what? These vertical lines, okay, x equals a. They're all what? Vertical asymptotes, okay, vertical asymptotes. So now we have the definition for vertical asymptotes on page 4. Okay. The vertical line x equals a is called a vertical asymptote of the function or the curve, whatever you call it, okay, y equals f of x, okay, if at least one of the following statements is true, okay, one of the 6, okay, as long as one of the 6 statement is true, then we call this vertical line x equals a is vertical asymptotes, okay. So I'm not going to repeat these 6 cases, but I hope you understand these 6 cases, okay. Alright, so find the vertical asymptotes. I put this is a star mark here, means you have to know how to find vertical asymptotes from a given rational function, okay? Because in the later chapters and the sections, okay, I will ask you guys to graph rational functions, and then there's one step is asking us to find the vertical asymptotes. So you have to know how to find the vertical asymptotes, okay? And then in the later sections we will learn horizontal asymptotes. You also need to master that as well, okay? So find the vertical asymptotes of this function y equals 2x over x minus 3. How can we find the vertical asymptotes of this function? It asks us to find these limits, okay, before we check the vertical asymptotes, okay? Let's find the limits, guys. When x approaches to 3 from the right, 2x will approaches what? 2 times 3, 6. And this 6 is positive number or negative number? It's positive, right? 2 times by positive 3 gives us positive 6. It's a positive 6. And how about x minus 3 goes to? 0. But was this 0 positive or negative? One, two, three. When x approaches 3 from the right, that means x is greater than 3, right? So, say the example, you can use x equals 3.1. So how about 3.1 minus 3? 0.1. Is that 0.1 positive or negative? I put a positive sign on the top of, right top of the 0 means this x minus 3 will goes to 0, but these values are greater than 0. It's a positive number. Okay? So we have a positive 6 over positive 0. What do you think? We know that usually 0 divided by a number, say 0 divided by 6 gives us what? 0. Remember this, okay? We learned this, okay? 0 divided by a non-zero number gives us 0. How about a non-zero number divided by 0? What is that?
Undefined.
Undefined, or infinity, right? Infinity, okay? So here we have a 6 positive 6 divided by 0. It should be infinity. But positive infinity or negative infinity? Positive divided by positive gives us positive result, right? So I would say this limit equals what? Positive infinity. Okay, if we do not write a positive or negative sign, that means it's by default positive infinity.
I never heard of someone doing a problem like that before.
Yeah, never. Well, that's fine. Okay, you never heard about these, right?
Right. Well, I know about undefined and stuff like that, but I never thought that you would use that method to get the asymptote of infinity.
Now you know, right?
Right?
Yeah. How about this limit? X approaches 3 from the left means x is less than 3. We still talk about top and bottom. The 2 times 3, right, is still 6, right, positive. And then this one, x minus 3, what goes to what? We know it's 0 because when x approaches to 3. However, what do you think about this 0? Think about when x is equals 2.9, right? 2.9 minus 3, negative 0.1, right? So negative. A positive number divided by a negative number, eventually the answer will be, what's positive divided by negative? Positive divided by positive will give us positive. Positive divided by negative give us what? Negative, right? These are basic algebra, right? So 6 over 0 should be infinity. However, we have a positive, we have a negative, so eventually it's going to be what? A very large negative number. You guys agree with this? Okay, now we see, when x approaches 3 from the right, okay, so the graph approaches to positive infinity, and then when x approaches 3 from the left, the y value approaches to what? Negative infinity. Well, how about the vertical asymptotes? Can you tell?
There's a vertical asymptote at 3.
Yes, x equals a. Okay, x approaches a from positive, from right, x approaches a from negative. Okay, eventually the equation will be x equals a. Okay, x equals 3 will be the vertical asymptotes. Okay, so vertical asymptotes, I use VA, you know that's for vertical asymptote is what? X equals 3. You can also see from the graph. Right, guys? So this is by the definition. What definition?
As long as one of the 6 statements, okay,
Is satisfied, we say x equals a is vertical asymptote. Now, I'm asking you guys to remember another way to solve for the problem, to solve for the vertical asymptotes. You don't have the graph, and in 5 minutes.
Well, the other one is x minus 3 equals 0.
Yes, very good, guys.
Just like x.
Yeah. Well, the key idea to find the vertical asymptotes is to make the y value goes to infinity, right? How to make the y value, the entire function goes to infinity? If the denominator goes to 0, then the entire function, fraction will go to infinity, right? So, yeah. Well, whatever past infinity or not infinity, we don't care, okay, doesn't matter. Here, so we let denominator x minus 3 equals 0, and we can solve for x equals 3, and then this will be the vertical asymptotes. So when you encounter rational function with a denominator, just let the denominator equal 0 and solve for x, then x equals 3, the vertical line will be the vertical asymptote. Can you try the next question? By using the method we just learned, but not a graphing. Can you find the vertical asymptote of this rational function?
oops. What do you do? Solve for x. You got it? Maybe. Can you tell us from here, from this line?
X is 0 and 3 halves.
How did you get the x equals 0 and the x equals 3 halves? Yeah, factor x out.
And you have x equals 0.
Yeah, the product equals 0 give us,
And then you have 2x equals 3.
yes.
And then from this is already 1. And then from this linear equation, we subtract 3 and we divide by negative 2, x we get 1. X equals 3 halves, right? And you have to know that, guys.
X equals 0, x equals 3 over 2. That's not the two values for x. It give us what? Two vertical lines, okay?
In the xy plane, x equals a constant, give us vertical lines, not just a value, okay? So when x equals 0, what is a line? Entire y-axis. This is when x equals 0, if we draw it. What is x equals 3 halves?
1.5.
Yeah, 1 and 2. So sometimes I use dashed lines, but here I'm going to use solid lines, okay? Well, I believe when we draw the pictures, we mostly use dashed lines, okay, for asymptote. These are, for example, vertical asymptotes, because these are like helping lines, okay? I would say this is a dashed line, okay? We use a dashed line for x equals 0, and then this dashed line is x equals what? 3 over 2.
Okay, so this is third part from section 1. This is 2.2, right?